All right. Today we're going to go through the second section of chapter 10. The first section we talked about different lines and segments like diameter, chord, secant, tangent, things like that. And we're going to continue to use those as we go through the chapter here. But today we're going to kind of take a side road onto what we call arcs, another very important part of our circles. So we're going to talk about how to find arc measures using what we call central angles. And so we start off with a couple of vocabulary terms here, which are going to be important. So a central angle, this is a really important one that we definitely need to make sure we know. It's any angle whose vertex is at the center of the circle. So any angle where I start at the edge of the circle, go to the center, and come back out to the edge. And that can happen anywhere. So I could put another one over here. That might be a little bit different size, or I could have whatever. As long as I have a starting point on the circle, a vertex at the center, and an end point on the circle, we have a central angle. Now, when we create those central angles, those points where we touch the circle, so in this case, B and A I have labeled. In between those points, we have what's known as an arc, an unbroken part of the circle. So it's not the whole circle, it's only a part of it. And so what I'm looking at is from point to point, that length around the outside of the circle is called an arc. And so that can happen anytime we have points within a circle. So I have an arc from A to B, or if I label these points up here, call them D and E. I have an arc from D to E, or I could have just a random point out on the circle, call it point F, and I have an arc between F and B, or an arc between F and D. So as long as I can connect 2 points on a circle, I'm going to be creating an arc. Now, as far as arcs are concerned, we have 3 main types, and we're going to kind of take this one step at a time. So the minor arc is any arc that's less than 180 degrees. Now, think about, as far as a circle is concerned, a circle is 360 total degrees. So if I start at point C and go all the way around my circle and come back, I'm going to travel 360 total degrees. But I know then that half of the circle, so only halfway from E around to A, would be half of the 360, or 180 total degrees. And so what a minor arc is any arc that's less than half the circle. It's less than 180 degrees. So that's kind of what we base it on. If I have the arc measure and it's less than 180, then I know it's a minor arc. Or if I look at the picture and I see it goes less than halfway around, I know it's a minor arc. Now, the arc measure will always be the same measure as the central angle. And so the arc and the angle are always going to be exactly the same value. And so, for instance, if I said angle CBA here was 48 degrees. So if angle CBA is 48 degrees, that means the arc from C to A. So the arc from one point to the other would also be 48 degrees. Or on the other side, so if this side is 48, the other side would have to add up to 180 with it. So if I take 180 minus 48, I would get 132 degrees. So there's my other central angle. That means from E to C, so this arc would have to be the same amount, 132 degrees. Both of which would be considered minor because they're both less than 180. They both go less than halfway around the circle. Now, when we name our arcs, here's the next part. We always name it with 2 letters. So if it's a minor arc, we only use 2 letters, the starting point and the ending point. So where I started and where I ended. So for my first one, if I'm going to highlight it in red here real quick, I went from A to C, so I would call it arc AC. Or the other one that I had kind of in those squiggly lines right here went from E to C, so I'm going to call it arc EC. And then we notice that the symbol is kind of like a line segment, but with a curve. So I'm curving that line segment symbol to make it an arc. And so that's what we're going to have as we're looking at minor arcs. The next type of arc that we're going to deal with is called a major arc, and that's an arc that's greater than 180 degrees. So again, we're kind of going off of that half a circle. And so if it's more than halfway around the circle, or if the measure is bigger than 180 degrees, then we know we're dealing with a major arc. And so when we look at the major arcs, anything more than halfway around the circle. So for instance, if I start at A and I go this way around my circle, so maybe I go this way around to point C. So now I'm looking at this big arc around this direction. That's going to be a major arc because I can see that it goes way more than halfway around the circle. Now when I label that, or name it I should say, I'm going to use 3 letters. Now it's not just where I start and where I end. If I only have 2 letters, I'm going to go the shortest distance between them. So if they say AC, I'm going to pick the smallest direction. So I'm going to go the quickest way from one to the other. If I want to go the long way, I have to specify that with a middle letter. So I'm starting at point A, and then I need to travel to point D, and then I continue on until I finish at point C. So the major arc, when I name it, it tells you exactly how to travel. Start at the first point, pass through the second, finish at the third. And that's what we're going to do every time. And so ADC goes all that way around. As far as the measures go, if we use the same measures that we had before, so we had 48 degrees, we had 132 degrees because those make 180. Now on this side, notice, because of this straight line, this angle over here is 180 total degrees. So if I wanted the measure of arc ADC, I could take the angles as I go around the outside. This A all the way around to E would be 180 plus 132 from E to C, and I could get that total measure. Or if I notice the only piece of the triangle I don't want is right here at A to C, and so I could take 360 degrees minus that 48. And that'd give me the same answer either way, and we're going to talk a little bit more about this on the next slide. The last type of arc is called a semicircle. And so in the semicircle, we're going exactly halfway around the circle. So for the semicircle, we're exactly 180 degrees, we're exactly halfway around, which will typically happen with a diameter. So if I have a diameter in my triangle, I'm going to automatically create a semicircle. And so when we name it, again, we use 3 letters because we have to know which direction to go. So if I start at A, I pass through point C, and I finish at E. So starting at A, I travel to C, and then I continue on to E. There's my semicircle. And the reason that's important is because if all I did was say AE, that could have been this side that we just marked, or it could even be this other side because I go from A to E this way too. The 2 letters tells us to go the smallest way. Well, both are the same because they're half the circle each way. So it's really important that you use those 3 letters to denote your semicircle so we know which direction we're heading. Now, as far as measures go, we already talked about the fact that the measures are exactly the same as the angles. So when they give you a problem that looks something like this and they're asking about what are the different arc measures, one quick thing to note here is we can add arc measures together, just like we did with segment lengths. So if I want the measure of arc EA, notice how E to A is actually comprised of 2 different arcs, E to C and C to A. All I need to do is, if I want to go from E to A, is add up the arcs as I go. And so in that case, that's just a matter of knowing my central angles. And so one of the first things I would always do in a problem like this is solve for all the angles on the inside. So notice we have a right angle here, which we know is 90 degrees. They gave us this angle was 42. And so we're missing this angle here, which we can get by subtracting from 90. So that's 48 degrees. And then on this side, notice we have the straight line, which makes this 180. So find those angle measures first, then we can find all of our arc measures. So for instance, for arc CA, we start at CA is right here. We identify where the arc is. Well, that's the same as the central angle. So that's got to be 42 degrees, and that makes it a minor arc. It's less than halfway, it's less than 180, so we know it's a minor arc. If we look at arc EA, E to A, we just got done talking about, is 2 arcs put together. So if I take both arcs and add them together, 48 plus 42, I get 90 degrees, which is still a minor arc. And then as I work my way through the picture here, my next one could be CE. So if I want to go from C to E here, we know that that's the same as the central angle, so it's 48 degrees. There's another minor arc. Now when we get to the next piece, I'm going to erase some of this here real quick just to make this a little cleaner. So they said this was 48 degrees. Now if I go to CAD, pick a new color here, C, pass through A, and continue to D. So now we're looking at this arc right here, and that's one of the things, is making sure we know which one to work with. As I work my way around, I'm going to add up the arcs as I go. So C to A was 42 because of the angle, and A to D is half of the circle, or 180. So I'm going to add those together, and I get 222 degrees, which is a major arc. And I could get that from the actual number, or the fact that I can see I'm going more than halfway around the circle. And then we continue on. We've got DE. So arc DE goes from D to E. That's the same as its central angle, which is 90, which makes it a minor arc. We've got D to C. Now D to C sometimes tricks kids, because when I go from D to C, they see that it's an obtuse angle, but that has nothing to do with what type of arc it is. When I add the two pieces together for DC, I get 138 total degrees, which is less than 180, which still makes this a minor arc. As far as DFA, if I get rid of some of this on the outside, make this a little cleaner. If I go from D to F to A, so D, pass around through F, and then to A, so I'm looking at this piece right here, notice that's half of my circle, or 180 degrees, and that's a semicircle. CFA is the last one, and so if I look at CFA, C is the starting point. I go around through F, and I end up at A. So I'm looking at this big arc from C the long way around to A. And so what I could do is add up the arcs as I go, 48 plus 90 plus 180, and that would give me a total of 318 degrees. Or if this from C to A is the only piece I don't want of my circle, I can take 360 minus the 42. I'm still going to get the 318, which makes this a major arc. So when we're working with those arc measures, it's just a matter of finding those central angles and then adding them together as we go. Last thing, and these are just a couple of quick theorems that we're going to see a little bit, but not really focus primarily on, so I'm going to just kind of talk about this real quick. Circles can only be congruent if their radii are the same. So if I have two circles, A and B, they're only congruent if their radii are exactly the same. So if I have a radius of 4 here and a radius of 4 here, those circles are the same size. Or the one that's probably a little bit more important is when I have congruent angles. So notice how those two angles are congruent because they're vertical. That means the arcs are also going to be congruent. And that should be pretty easy to show, because if this was, say, 40 degrees and this was 40 degrees, that means this arc would be 40 degrees and this arc would be 40 degrees. We can see they're the same. So if I have two angles that are the same measure, then the arcs are going to be the same measure. I could even add another angle here, and if I say it's congruent to the other, so if it's 40 degrees, then its arc is also 40 degrees and the same. So that one's a fairly intuitive, straightforward one that you can use as well. So with all that, you should be able to work on the worksheet, which you can get from class or on Google Classroom. Make sure to check the answer key as it becomes available and ask any questions you might have as you're working through it.